Okay, we can go ahead and get started. So lots of announcements. Let me see if I can get through everything. Normally, I show you the results of the question of the day at this point in time. They were very interesting, the results. You know, this was the question about what was your least favorite homework assignment. You might have guessed that I plan to have today's question of the day be, what was your favorite programming assignment? So I'd rather not prejudice the answers to the new question by showing you the answers to the old question. So I'm going to show them both on Friday. So I think it'll be interesting to see the combination of those two. So I'll be adding that new question, about your favorite assignment, and on Friday I'll show you the results for both questions at the same time. I sent out an email message to the class that you should have all gotten, mentioning that because of all the things we've been dealing with, new things we've been dealing with in addition to dealing with the virus, that I have extended the due date for critters to tomorrow, so Thursday at 11 p.m., and I've extended the cutoff date from Sunday to Tuesday. So you have until Tuesday 11 p.m. to complete the critters assignment. I put up links here to your course evaluation. You probably are getting emails from the university as well, encouraging you to do that. I mentioned last time, let me mention it again, that I give a tiny incentive for you to do this. I give people 1/3 of a homework point if you fill out the evaluation. When I started doing this, by the way, when I started giving the little tiny 1/3 of a point, my scores actually went down. So I think it's not necessarily helpful to me in terms of trying to get high scores, but what it has done is to gotten a broader range of students to fill it out. So I think it's worth doing. I'd like to see as many people as possible fill out the survey. I compute some statistics about this at the end of the quarter, and last time what I found is that the students who filled out the survey had a full letter grade higher than the students who didn't fill out the survey. That's not because filling out the survey somehow gets you a higher grade. As I said, just 1/3 of a point. It's a very tiny little bit of incentive. But I think in a way, maybe it's an indication of engagement. Are you still listening to the lectures? Are you doing the things that we're asking you to do? And I guess it's an indication that it matters. I mean, there was a full letter grade difference between those two groups. So please fill out an evaluation. You get the tiny bit of credit. I won't know what your answers are. I'll just know that you did it. That's the only information I get. The critter tournament is going to be on Friday, and I posted this link to the critter tournament rules, so you can read all about that on that page. So it tells you how it's going to be run and so forth. And on that page, there's a link here to do your critter submission. So you have to do a separate submission in order to participate in the critter tournament. It'd be great if we had lots of people submit. I mean, you could always submit. I mean, maybe your critter won't be chosen because we do this kind of pre-contest to pick the top critters, but hey, why not give it a shot? And we do pick, I mentioned in here, that we pick 4 critters on the basis of them being entertaining. So if you have some idea for how to make your critter entertaining, that's another way to participate in our tournament and to become a winner. So if you're so inclined, submit a critter for this. This is not the same thing as submitting it for your homework. So you can submit a totally different thing for your homework, and maybe you're not ready to submit the homework yet, but you submit a critter for the tournament, and that's fine. So this is a separate kind of submission just for the tournament. I do mention in here, don't call it Husky, because they can't all be called Husky. So come up with a name like Regis Husky or something, some name that's different, so that the different critters will be distinguishable, different class names. So I hope we get lots of participants. Friday should be fun, to be able to do the critter tournament. So I kind of wanted to remind you about that. I have posted final exam resources. I think I mentioned this last time. Similar things to what I had done on the midterm. And in fact, in a minute, I'm going to spend a little bit of time talking about that. So let me give you the pitch for why it's worth studying these things, even though we aren't going to have a final exam and we're not going to have a homework assignment that builds on this. I guess what my advice would be is watch today's lecture, because I'm going to go over some examples of array manipulations that are a little bit more than what we've done before. I think it's really important for you, even if you're not going to go on to 143, particularly if you're going to go on to 143, but even if you're not, just kind of practical skills, it's good to kind of complete your training, so that you know how to do these things. We're going to follow up in section tomorrow. We're going to be talking particularly about array lists and arrays and doing some extra problems with that. So listening to today's lecture, participating in tomorrow's section, maybe some of you need tomorrow's section in order to complete your participation points. That would all be a good thing to do now. Now, in terms of sample tests, I mentioned at the midterm time that I thought this is a useful thing for you to do, is to try doing a sample test. And I still think that would be good, particularly those of you going on to 143, that it would be helpful to try doing one of these tests. I've given you 2 complete exams, just like I did for the midterm, so that you could do that. Now understand, doing the sample final, obviously you're going to want to finish the homework first and finish your other classes first. So, maybe if you're going to be doing stuff with the sample final, maybe that comes after everything else that you're trying to deal with this quarter. But in any event, I think watching today's lecture and participating in section tomorrow will be helpful to you. So anyway, I've got the information about the sample exams. I wanted to say a little bit about the different problems that are on this. Normally I'd be spending more time on it because students would be really nervous. They know that they're going to take an exam, but some of what I tell them might be helpful for you to know too. So there are fewer mechanical style questions that I normally include on my final. Just these 3, are mechanical style. There's a reference mystery question where you have to understand parameter passing and what we've been talking about in terms of reference semantics. There's an array simulation problem, and the array simulation, well, actually I would say both of these questions, they're things that you can study for, that you practice makes you better at it. So I'm surprised. I have a little note on my notebook here where I've written down the average scores I've been getting on these questions. Overall, for the test overall, I've been getting an average of around 71% on the test. On these first 2 questions, I've gotten an average score of 80%. So, higher than the 71 overall average, but still not that high, given that they're mechanical style questions. On the midterm, the mechanical style questions tend to get more like 95%, as the average score. So these are things that I would have expected higher scores. It kind of tells me that some people are not preparing as well as they could. And my guess is anybody watching this lecture is probably not in that group. So, I can't reach the people that I should be talking to about practicing these things. So I think it's good to practice those. The inheritance question has had an average score of 95%, so that one's kind of worked out. People have prepared themselves for that. Chapter 6, we did file processing, and I have been making a distinction between ones that involve just token-based processing versus entire lines worth of processing. So I've kind of split it into 2 questions. The average here has been around 75%, so a little higher than the overall average, but not quite so high because it's a programming question instead. In the line-based processing, I often do some string manipulation because just reading in the lines is usually not enough to make the problem interesting. So I often have you do something that involves showing me that you know how to manipulate a string, like we did in assignment 7. So that's something that I often incorporate into the line-based processing question. I have several different array questions. So there's kind of the easier 10-point arrays question, and then there's kind of a harder 15-point arrays question. And I'm going to give you an example of each one of those the examples we're going to look at in a couple of minutes. So typically the 10-point question involves some variation of a simple traversal. And the good news is people tend to do fairly well on that. The average score is 80% on that particular question. So that's pretty good. The other questions, these 3 tend to be the harder questions, including array list, which is a little surprising to me because the array list, again, could be something that's not quite so hard. Sometimes it's because people they didn't watch the lecture on Monday, or this happens even when there is a final exam, that students maybe don't go to that lecture or don't know about it. So some students are kind of clueless the day of the test. But in any event, so the average scores here have been 68% on the array list question, which is a little disappointing. I think it's because they didn't do the work, to kind of learn the material. And there's interesting algorithmic twists. We saw some even in what we did last time. I ask a critter style question that gets an average score of around 70%. Usually what I do on a critter style, I ask you to write a complete critter class, and there's a lot of points for what you might call boilerplate code, standard code, just kind of having a class header, having method headers for get move, for get color, for toString. So some very basic type things get you a floor of a certain number of points on this question. But then there's always kind of what makes the question hard is, like with the homework, having to figure out what state information you need and how to update that, what fields, and how to update those fields in order to get the behavior that's being described. So it's kind of clear, there's a little bit of a bimodal distribution where there's a good chunk of students who get very high scores on this question. It seems like they mastered the critter kind of problem, and then another group who don't do so well that seem to still be confused about things like what fields and how to update them. So in any event, you kind of see a split there between the people who seem to have really gotten it and the ones who haven't gotten it so much. So it is the object question on the test, and so it's worth your while to be practicing this, especially if you're going on to 143, so you're prepared. The last question is the last array question is a kind of harder array style question. I'm going to give you an example and say a little bit about what tends to make for harder array style questions. This one's had an average score of 63%. So hard, arrays can be hard, so that tends to be something that students don't get quite so high of a score. And like on the midterm, I have a question at the end that's, I let myself pick among anything. Typically it's either an array question or a string-based question, but I kind of don't say in advance what it's going to be. And probably the points for this question should be a lot more than the 10 that are here, but this is just as a way of distinguishing at the very high end, kind of the distinguishing in the A-B range, so I don't want to destroy people if they don't see how to do that last question, so that's why I limit the points to 10. Anyway, you can see what some of those old questions were. The average score on that is around 40%. So, we give a fair amount of partial credit for a correct header and for pieces of the solution that students were able to figure out. All right, so that's kind of an overview of what's in the test. As I said, I encourage you to do a sample final yourself, probably later once you've finished all of your work for the quarter. Don't make it too late, though. I don't know about you, but for me, I always tell myself, I'll rest for a few days. I'll take a little vacation time or something, and I will get back to it. I swear I'll get back to it, and then I never do. So, I would recommend that before you think of yourself as being done for spring quarter, that you try to fit this in, although obviously it's going to be after you finish all of your other coursework. And some of you won't be able to fit it in, and I guess that's okay. All right, so I want to go over some array-style questions. And the first one is, all three of these actually are getting at things that we didn't talk about directly in lecture, particularly the second and third one. This is kind of a good way of thinking a little more about arrays. We had some lectures, you did a homework, but I feel like arrays are really important to master for practical programming, for people who don't go on, but or even if you go off and program in Python, if you use Python lists, you're going to do similar kinds of things. So kind of knowing how to do this is important in general, and it's particularly important for those of you going on to 143. So I've got a little program here. The idea is I've got some sample problems, 3 sample problems. I'll post it to the calendar for today, so it'll have the solution to all of these 3 problems. I set up 3 arrays here, print out what's in them, and then the first problem I want to do is this is sorted. So it's going to kind of print out the result of the is sorted. So here's a description of what we're supposed to do. Write a static method called is sorted that takes an array of integers as a parameter and returns true if the integers appear in sorted, non-decreasing order, false otherwise. So it's a public static method with some kind of a return type. It's called is sorted. It says that it takes an array of integers as a parameter. So it takes some list of integers in an array as a parameter, and it returns true or false. So what is that? If it's returning true or false, that's a Boolean return. And we haven't practiced that quite as much either. I mean, I mentioned it for the midterm, but this is something that's important for you to understand. Even especially if you're going on to 143, but even those who aren't, there's a lot of methods in the Java class libraries that have a Boolean return type. So kind of getting used to that is an important thing. So what are we supposed to do? We're supposed to see whether the sequence of values in the array is in sorted order. So I mentioned that this is like a 10-point question. In fact, I've used it as a 10-point question. So standard traversal is a good place to start. Int I equals 0, I less than list.length, I plus plus. Do something with list bracket I is going to be kind of our standard thing. But what do we want to do with list bracket I? So if we looked at these values here, they look sorted for a little while, or at least these two, and then that's not sorted. They're supposed to be in increasing order, the sortedness. So how are we going to do that? We have to, I think the key to understanding this question, this is something we didn't discuss as much, so that's why there's a little bit of extra here, is that, list bracket I would be, say, this value right here when I is 0. We start by looking at the very first thing in the array. But you're not going to kind of get this just by doing something with the I value and then the next one and then the next one and then the next one. There's a key insight into this problem, which is that you want to look at adjacent pairs. So you don't want to look at 8 by itself. You want to look at 8 relative to 12. And what you'd notice is that for the 8-12 pair, adjacent pair, they're in sorted order. That looks good. But what happens when I move over, when I becomes 1, then I'd be looking at this pair, this adjacent pair. And when I look at 12 versus 4, that's not in sorted order. The 12 is bigger than the 4, so that's not sorted order. So that's the kind of thing that we want to do inside of this loop, is we want to be dealing with an adjacent pair. We want to know something about list bracket I relative to list bracket I plus 1. So we want to be looking at an adjacent pair of values. We're at index I, 0 initially. We're looking at the I plus 1. So say 0 versus 1, 1 versus 2, 2 versus 3. We want to look at an adjacent pair. And so, what we hope is true is that the earlier value is less than the later one, like what we had with the 8 and the 12. So we could check to see whether it's less, but that's not that helpful. Kind of knowing that it's less doesn't tell you the important thing. The thing that matters is when you see something where it's not less, when you've got like a 12 and a 4. So we want to be looking for not kind of the good ones, but the bad ones. So if list I is greater than list I plus 1, if the earlier one is bigger than the one that's next to it, well, then that's not in sorted order. So that means we figured out that this is not a sorted array. And I've mentioned this idea, it comes up in programming a lot, but particularly in some of these array problems, is that we now know what answer we want to return, which is we want to return false. We want to say if the adjacent pair is out of order, return false as a way of saying not a sorted array. I mentioned at the midterm time, I'll mention it again, that for some reason students kind of feel inclined to do something like this, to make it an if-else, where you're returning false or returning true, and it's the wrong thing to do. I mean, what that would do is that, initially when I is 0, it would compare this to this, and it would find that they're in order, and it would go into the else branch here, and it would return a true, because the first pair, satisfied it. In fact, this version of it never looks at more than one pair. It kind of it makes a decision immediately based on the very first pair. So this would be a very bad thing to do. I mentioned at the time of the midterm that we refer to that as stopping early, returning early. We don't want to return at that point. There's a kind of a pattern. I mentioned it briefly with the midterm, but I'll kind of mention it a little bit more here. I sometimes refer to it as the innocent until proven guilty pattern, which is we assume the array is innocent, we assume the array is sorted, that it has kind of the property we're looking for. But as soon as we see evidence of guilt, that this pair is out of order, then we say, nope, I know that that's not true. So we don't want to return true here. When would we know that it's overall innocent? And that would be at the end of the trial or whatever, when you've heard all of the evidence and you found nothing that made you think that there was guilt here. You've looked at all of the pairs. You didn't see any pair that indicated that there was something out of order. After the for loop, we would return true. That's a way of saying, oh, well then it was innocent. It is sorted because we looked at everything and we didn't find any pairs that were out of order. You might wonder whether this should be greater than or equal to, and it's good to think about things like this. The problem statement, the fact that it says non-decreasing, and there would have, if this was an actual exam problem, there'd be examples of this. If you had an array that had like 3, 3, 3, 3, 3, so that's not going down, it's not decreasing. We would call that non-decreasing. They're all duplicates, right? So it's actually okay if two adjacent values are equal to each other. So actually, we do want strictly greater. That would be the thing that would be a case that would be of concern. Greater than, equality is not a problem. There's a different problem here. I bet a lot of you have noticed it and are thinking about it, that this isn't right. It's almost right, but there's a minor glitch in this. And that's, it's one of the nice things I like about a question like this, is that there's little things to get right, and, there's usually a range of scores on a question like this, because different students recognize different things. Some get all of the little details right, some people miss a detail. But let me mention it this way. If, for example, let's see how many numbers there are here. 1, 2, 3, 4, 5, 6, 7, 8. There are 9 numbers here for us to be considering in the array, but there are only 8 adjacent pairs. So 9 numbers, but then there's 8 adjacent pairs. This pair to look at, and then this pair to look at, and then this pair to look at. So there are 8 adjacent pairs. When we get up to this one in the array, it does have an adjacent value next to it. But if we allow I to get to here, and we ask for I plus 1, we'd be asking for something beyond the bounds of the array. I mentioned this briefly, but I don't think I ever wrote this down, that there's a term that I sometimes use, that some computer science instructors use, OBOB, off by 1 bug. And OBOBs are very common in array-style programming. So we don't want to let I go that high. We don't want it to go to the list.length -1 thing. We throw in a -1 to stop it 1 earlier than that. So we don't want a full traversal. We don't want I to go through every possible I for the array. We want it to be 1 less than that, one earlier than that. I think this is going to work, but let's take a look. We can compile it and run it. And what it says is that list 2 is not sorted either. List 2 is sorted for a long time, but then it kind of stops being sorted here, right, when we go to the 96 to the 2. But this one is in sorted order. So false, false, true is the right thing for it to be showing. So that seems to be working. All right. The next problem I want to do with you is a kind of an intermediate problem. So let me uncomment. This is more than what I would tend to do in a typical 10-point question, but a little less than what I do in a 15-point question. So it's an interesting medium one to be thinking about. So let's read what the problem statement says. That's down here at the bottom. I have these slightly out of order, but that's fine. Write a static method called rotate left that takes an array of integers as a parameter and that rotates all values to the left by 1 position. rotating the first value to the back of the array. For example, so if you had 1, 2, 3, 4, notice that this value 1 that's at the front ends up at the back of the array, and these other values, the 2, 3, 4, they all get shifted to the left by 1. They all move up by 1 in the array. So it's a little like a 10-point question in that it'll involve a traversal, but it's a little trickier than what I would tend to do with a 10-point question on the exam. So it's a static method, public static, I don't know what the return type is, rotate left, that takes an array of integers as a parameter. Does it say anything about returning? I don't think so. So that means it would be a void method. And as I said, it's kind of a little bit of an in-between between what we would do with a 10-point question and what we would do with a 15-point question. So standard traversal is not a bad idea. For int I equals 0, I less than list.length, I++ is a good way to start. And then inside of here, obviously, do something with list bracket I. Well, what are we going to want to do, with the list bracket I? So let's think about it. What happens when we're here, when we're at index 0? Well, in the final version of this, what's supposed to be at index 0 after the rotation is the value that's at index 2. So there is kind of an adjacent issue here, that the value, so when we're positioned at index 0, when we're dealing with the position 0, we want to put into that spot the value that's just to the right of it, the spot, the value that's at the index 1 higher than that. In other words, we want to be changing list bracket I, and what is it we want to set list bracket I to be? We want to set it to be what's in I+1. That's kind of the shifting code. And one of the things that I've found is true is that shifting code is harder for students to write. When you're dealing with code where it's always I, or even the code we wrote here where you're comparing against an I and an I+1, that's not quite as complicated as here when we're actually moving things inside of the array. We're moving values from one spot to another. So that's why it's worth going over an example like this, because it is a little bit tricky. And I really miss the audience because I'm usually getting tons of suggestions from students. Do this, do that, think about this. There's all sorts of issues here that we have to be thinking about. So so what is this going to do? When I is 0, the 2 that's positioned here is going to be put in index 0. So, and then when I becomes 1, the value 3 is going to be copied there. When I becomes 2, the value 4 is going to be copied there. So there's usually 2 big things that people are thinking about right away. One of let me do them, again, it would be great to have an audience that could give me suggestions, but so I'll just pick, the order I want to do them in. Look, if the very first thing that we do is we put a 2 here in list 0, we overwrite list 0 with a 2, then what happens to the 1? What happens to the value that was there? This is a little bit, remember we did some swapping code, and with the swapping code, we had to have a temp variable that would keep track of something before we overwrote a value. This is like that. This is like a super, swap. It's like a big rotational swap. So we know that when I is 0, it's going to be overwriting what's in list 0, so we'd better use some kind of a temporary to keep track of that. So I'm going to say int first is list bracket 0. I'm going to remember what value was in index 0, so before we overwrite it. Because then, so I will store away the 1 so that it's available to me, and then I can put a 2 here, I can put a 3 here, I can put a 4 here. And then in the standard traversal, we're going to get up to this index right here, the one that's list.length -1, and it's going to try to grab a value that's, adjacent to the right. It's going to be looking ahead to try to grab a value, and that's not going to work because there isn't a value to the right there. So it's another OBOB. We have another off by 1 bug here that when I gets that high, We don't want to be doing this. So we do a -1 so that we stop one early. We don't do that one in this way. And we just kind of do that last one manually. Well, what's the index of that last one? It's not at list.length, because remember, it's going strictly less than list.length. It's list.length -1. All the way back to when we first introduced arrays, we talked about the idea that list of list.length -1, is the way of referring to the final value. So that's this index, so that would be the index right here. We're kind of, going to set that one manually. And what do we want to set it to? Well, it's supposed to be set to the value that used to be at the front. So we can just kind of say this is assigned to front. So we use a temporary variable called first to remember that first value. And at the very end, we put that into the final spot in the array. And in between, we use a loop to do the standard shifting kind of code. I didn't intend to introduce any errors there, but we'll try compiling. What did I? Oh, not front. It would be good to use the same name. First. Maybe a bunch of you noticed that. Actually, that would have been a good thing to do on purpose. I didn't actually do it on purpose, but it would be kind of sometimes it's good to introduce these little mistakes. Keeps you awake, that you notice little things and it's not going to work, and Stuart's going to be confused. So anyway, that would have been a good thing to do on purpose, although I didn't. What I do here is I have some code in main that's going to kind of show what's in the list 1 to begin with, and then it's going to, for the length of the array, for however many things are in the array, it's going to rotate, print, rotate, print, rotate, print. So I think I did the compile already, but we'll go ahead and let it go, and let's see what we get as output. And what it shows us is that's the original array, so that was what we had. That was the 8, 12, 4, etc. That was before rotation. And then what ends up happening is that the 8 gets shifted to the end, which is what we wanted, and those other values in the array, they all got shifted to the left by 1. So we've written the shifting code that shifts that all to the left by 1. That was what the loop did. And then kind of manually, we tucked away the 8 and then put it there at the end. And then we do a similar thing with the 12, putting it here, and we let the array, the rotating, shifting code in the array shift these things to the left by 1. And we keep doing it, shift left, shift left, shift left, rotate left, rotate left, rotate left. And if you do it exactly the n times, where there's n things in the array, if you rotate it n times, it rotates back to where it was to begin with. So that's kind of a little bit of a double check, is that we end up with exactly the same sequence of values we had to begin with, because it's a full set of rotations. Rotate all the way back to the beginning. Any questions? It's too used to saying something like that. I wish I could do that, but obviously we don't have that option available to us. Okay, so as I said, that's a little harder than what I would tend to do on a 10-point question. Not quite as hard as what I would do on a 15-point. This one is a great example of a 15-point question, and it gets at kind of all the things that I want to talk about for a 15-point question. And it's getting at some issues we haven't discussed about arrays. So let's take a look at this problem, something called interleave. I have an interesting history with interleave, which is almost any time I've ever asked students to solve a problem called interleave, the scores have tended to be very low. So I decided to stop giving it as an exam problem and just do it in lecture instead. Write a static method called interleave that takes 2 arrays of integers as parameters and that returns a new array that contains the result of interleaving the elements of the 2 arrays. A whole lot of words that I just read there. Public static method called interleave that takes 2 arrays of integers as parameters. So let's have an int bracket bracket list 1 and an int bracket bracket list 2 that takes 2 arrays as parameters, and that returns a new array. So it's going to return an array, and so its return type is going to be int bracket bracket. This is a problem where this header is complicated enough that I might have very well made the header worth 2 points, because there's a lot of things to have gotten right in that header. 2 of the 15 might have been just for writing that header. And then what does it say to do? That you're supposed to interleave. Two arrays are interleaved by taking elements in an alternating fashion from the two lists. First value of first list, first value of second value of first list, second value of second list, etc. So let me actually, let me use the sample list here to describe it to you so that you understand what we're supposed to do. We're making a brand new array that's going to have stuff in it. So we leave the original arrays alone. We make a brand new array. And what's supposed to be in that array? The first thing in that brand new array, suppose we're interleaving list 1 and list 2. That's the order that we passed parameters. Well, then the first thing in the new array should be the first thing from the first array. The 8 should come first. Then we should have a 42, the first thing from the second array. So we take 1 from the first array, 1 from the second array. That's our first pair. Then we would take the value 12, followed by the value 84. So we take the second thing from the first array and the second thing from the second array. So then we're going to have a pair that are the third values from each array. So you could almost kind of imagine, I've sometimes called this weaving, that you're kind of weaving things together. So we take an 8 followed by a 42, then a 12 followed by an 84, then a 4 followed by a 92, then a 0 followed by a 96. So kind of the weaving pattern, interleave to kind of take things from each. So it's going to end up with more values because it's kind of taking one from each and putting these things together. Now this is a case where list 1 does not have as many values as list 2. So how do we deal with that? The problem statement says if one list is longer than the other, ignore the extra values. So we're going to interleave as long as we have pairs, something from each, but if we run out of one of them, we stop, and then we just ignore anything that's left over in the other list. So again, I'd ask for suggestions on how to solve it. I get tons of interesting responses from students. A really nice thing about this problem is that there's tons of ways to solve this problem, so, that seem completely different, all of which work. So that's a kind of a nice thing too, is that we've gotten to a point where we have some problems. When we deal with misconduct cases, people will sometimes say, well, there's only one way to solve this thing. Sometimes there aren't quite so many ways of solving things, but more often in programming, there's tons of ways of solving things. And that's certainly true here, that there's a lot of different ways of solving this problem. I'm going to talk about it by first talking about a kind of a general outline. What would be the steps involved here? We're supposed to return a brand new array. Well, where does the brand new array come from? So one of the things that we're going to need to do is to construct the new array. Before we can do anything else, we're going to have to construct that new array because we're supposed to return a new array. So how are we going to do that if we don't construct it? Then fill in the new array, as kind of a second step, and then return it. That's kind of a broad outline of what it is we want to do. Construct, fill in, return. And so we know that there's going to be something here that kind of involves int bracket result equals a new int array with something here. And we know that we're going to have some code in here that will fill in the new array. And then we're going to want to say return result. So we know that we're going to, that's an outline. We know that we're going to want to do at least that kind of thing. Construct the new array, fill it in, and then return it. This is a problem, too, that has lots of little details to get right. Like people will, the hard part here is filling in the array. That's worth most of the points on this question. But these other things are worth points, too. A lot of times I'm surprised that someone who got this hard part right then forgets to do the return. So, I want to be careful whenever I solve a problem like this that you kind of get the different pieces of it right. How big do we want the brand new array to be? So that's a challenge. Again, I get interesting answers. It involves thinking about arrays that have different lengths. So like suppose one of them had 10 values and the other one had 15. Well, then how many are going to be in the final array? There are 10 values where they're matching pairs. The shorter array has 10 in it. So 10 times, we're going to be able to do the interleave, the weaving operation. So we'll get 10 pairs that give us an overall array that's 20 long. And if you think it through a little bit, you'll come to realize that we want to know what's the length of the shorter array. It's not bad to put that in its own little line of code. We want to know the minimum size, kind of what's the shorter of these two. If one is of length 10, one is of length 15, we'd want to know that 10 is the number we're working with. How do we get the minimum of two numbers? You could do an if-else. There's different ways of doing it. Math.min is the easiest way to do that. And what are the two numbers? We're trying to find the shorter length. Well, those lengths are list1.length and list2.length. So we can call math.min to figure out which one is shorter. And then we can basically say that I want something that is 2 times min. That my resulting array should be twice the size of the shorter array. And this would be worth actually a good little chunk of points on a problem like this, is being able to construct the array properly. Notice that you need to return it even if you don't figure out how to fill it in. It's always good to kind of be able to show what you can show. All right, so now let's kind of talk about the hard part. Let me say what I think is hard about this. And this is true of most of my 15-point array questions. And it's kind of an indication of what we haven't really practiced, what you didn't practice in homework. But it's something that is an important thing to understand. Even if you go off and program in Python, this kind of thing is going to come up in all of these programming languages you might work with. So here we're going to want to do something where we have result of something. That's our result array. It's going to be assigned to list 1 of something. We're going to want to copy some things from list 1 into the result array. Some of the values from list 1 get put into the result array. We're also going to want to execute lines of code that look like this, list 2 of something. So we're going to want to be executing both kinds of lines of code. That sometimes what we're putting into result is something that's coming out of list 1, and sometimes what we're putting into result is something coming out of list 2. And we got to figure out how to do that for all of the different values that we need to copy. That's the challenge. But what makes it tricky is that what you're going to put here inside the ... is different than what you're going to put here where I have the ... So it's not going to be result I and list 1 I. It's not even going to be something like result I and list 1 I plus 1. I plus 1 is already, different indexes, but they're adjacent. They're very close to each other. What makes this hard is that these are going to be very different. What we put inside brackets for one versus what we put inside brackets for the other is going to be very different. And that's what makes this kind of problem hard. And that's why it's worth practicing, to kind of make sure that you have mastered this before you go off to do programming and practical programming in Java, or learn how to do it in Python, or take the 143 course. You want to kind of have thought about this kind of a situation where what goes inside the brackets doesn't match. Well, let me talk about that for a minute. So basically, the values from list 1 at indexes 0, 1, 2, 3, etc., where do they go in the result array? So let's think about that. Let's use this example I was using before. This thing goes into, it's at index 0 of list 1, and it goes into index 0 of result. So 0 goes to 0. Then we would put this into index 1 of result, which means that this would go into index 2. So the value at index 1 of list 1 goes into index 2 of result. And then this would go into index 3, this would go into index 4. And if you kind of notice the pattern there, the weave pattern, this goes into index 0, 2, 4, 6, 8, and so forth. So let me write that down. These things go into indexes 0, 2, 4, 6, etc. And This is all the way back to chapter 2, when we were looking at sequences and trying to come up, a multiplier and a constant. How do you kind of turn one sequence into another sequence? If you've got one sequence that's going 0, 1, 2, 3, the other sequence going 0, 2, 4, 6, obviously we need a multiplier of 2. There's going to be a 2 times in this. Or depending upon how you do it, a divided by 2. So there's kind of different approaches, one of which would kind of lead to the times 2, and one of which would lead to the divided by 2. So that's kind of where values from list 1 go. How about the values from list 2 that are at 0, 1, 2, 3, etc.? Where do they go? Well, I think you can see where they go, but, I'll just kind of mention it. This one ended up at index 1, the first one at index 1. This is at index 3. This is at index 5. It's the complement of that, the other indexes. Index 1, 3, 5, 7, etc. So in the odd indexes. So there's going to have to be a 2 times I with a plus 1 in there. This is again back to chapter 2. How do you come up with a multiplier and a constant to make an expression that turns the one sequence into the other sequence? Well, this suggests a certain way of solving the problem that I'm going to mention. It's kind of my preferred way of solving it, although I'm going to show you or mention another way that's just as valid, and it's just kind of a different approach. So I'm going to think of it this way. I'm going to think of, for in I equals 0, I less than list 1, list 2 dot length, I plus plus. I'm going to think about looping over list 1 and looping over list 2. So I kind of want a standard traversal loop. And the idea here is that the array that I'm thinking of looping over is list 1. Well, but there's 2 of them, list 1 and list 2. So kind of, what length do I want to use? Well, the whole point was that I came up with computing this min. There are min things that I want to take from each of list 1 and list 2. So I kind of want to be doing the 0, 1, 2, 3, as I go through list 1 and as I go through list 2. So some of these result sub something is going to be assigned to list 1 of I, and result sub something is going to be assigned to list 2 of I. So I'm kind of looping over the list 1, list 2 combination, getting the I value from each of list 1 and list 2. So my loop is looping, so I get a pair of values when I is 0, I get a pair of values when I is 1, I get a pair of values when I is 2. So I'm looping over the list 1, list 2 combination rather than looping over result. That's kind of a different way to go, would be to loop over result. And so then what do I end up doing in here? Well, if I have 0, 1, 2, 3, I have the I from list 1, how do I turn that into 0, 2, 4, 6? Well, we talked about how to do that. That's a multiplier of 2 times the I. So, we want the value at index I from list 1 to go into the spot 2 times I in result. So we do that with the min things coming out of list 1. And how about for list 2? Well, they're supposed to go into odd indexes. So there's again a 2 times I to get things that go up by 2 every time. But multiplying by I by 2 gets you 0, 2, 4, 6. To get the 1, 3, 5, 7, we have to throw in a plus 1. So we have to throw in a constant. This is the chapter 2 stuff, to kind of be able to come up with these linear relationships. So the odd indexes of result get populated with things that came out of list 2. Let me try compiling, and we'll try running this version of the code. And remember, let's see, list 1 and list 2, they're way, let me take a look at them up here. There's the, we said we wanted 8, 42, 12, 84, so 8, 42, 12, 84, 4, 92. You can kind of see that it's got the weaving pattern that we were looking for. So that is a solution to that problem. Okay, let me mention the other idea and kind of leave it up to you to think about I'll include it on the calendar for today in case you're interested. But kind of another way that works is to have a for int I equals 0, I less than min, not min, but result.length. So to kind of to go over the result array. So I is the bigger I rather than the kind of the shorter I. And so what you'd have to have inside of here is some kind of an if-else, where sometimes you were taking from list 1 and sometimes you were taking from list 2. This is a good little problem for you to work on. I'm going to leave it to you to kind of think about that. What would be the test you would use to know whether to take from list 1 and list 2? And here we'd be wanting to turn an index like 2 into the index 1, or an index like 3 into the index 1. And so there's going to be here, instead of a multiplying by 2, there's going to be a dividing by 2. So again, that's a good little exercise that I'll leave for you to think about. I think I did forget to mention one thing about rotate left, which is there is a special case to think about that I didn't mention. Is there some array that this causes a problem? And it turns out that the empty array would be a problem here. There's no list 0 to work with. So you'll see in the version that I'll post today, I had an extra outer if that kind of said only do this if it's a non-empty array. Okay, well, that was all of those problems that I wanted to talk about today. I encourage you to participate in section tomorrow. Turn in a critter by tomorrow noon if you want to be part of the critter tournament, and I'll be back on Friday to run that tournament. I didn't mention there will be prizes. I mean, not terribly valuable, but Amazon gift certificates for the top 4 winners and the entertaining winner. So kind of 5 prizes total for our contest on Friday. And I hope some of you will tune in for that, because I think you'll find it fun. All right, that's it for today.